So yesterday we introduced Chapter 2 with 2-1, which was solving equations by adding and subtracting. Today as we move on to 2-2, we're still solving equations, but we're multiplying and dividing today. So we're solving still one-step equations with one variable, but we're using multiplication and division to solve. And in this case, solving means get the variable by itself, or find the value for the variable that makes the entire equation a true number sentence. So this first problem says -4 is equal to k over 5, or -4 is equal to k divided by 5. Because this is a division problem, we're going to use multiplication to undo that division. I want to undo k divided by 5. So the opposite operation there, the inverse operation, would be to multiply times 5. If I multiply one side of an equation by 5, I have got to go to the other side and multiply that by 5 also. 5 times -4 is -20, and that equals k. Because these 5's, multiplying by 5 and dividing by 5, cancel out, because 5 divided by 5 is 1. So we get k by itself. Like we talked about yesterday, if you wanted to check this, you take your original problem and you plug in your value that you got for the variable. We got -20, and we're just going to check this. Does -20 divided by 5 equal -4? It does, so we know with confidence that we got that problem correct. Our answer, k, is equal to -20. As we go to the next problem, I see y divided by 3 equals 13. So mental math says, what number, what value divided by 3 leaves me with 13? So you could do this one mentally, or you could solve it using algebra and saying, I know if I undo divided by 3, I can multiply by 3. And I know if I multiply one side of an equation by 3, I have to multiply the other side by 3 also. 3 times y divided by 3 leaves you with just y. 13 times 3 is 39. So y is equal to 39. If you wanted to check it, you would take your 39, divide that by 3, and just double check that it equals 13. 39 divided by 3 does equal 13, so you know you're correct. And the reason this math works out for us is when we have y divided by 3 equals 13, and we multiply both sides by 3, we're really multiplying by 3 over 1 on both sides. Well, 3y divided by 3 is the exact same 3y divided by 3, or 3/3 of y. 3/3 as a fraction would simplify to just 1. Y equals 39. So this is kind of the math behind what we're doing. Okay, and I do not ask that you show that work, as long as you show me the work of just multiplying both sides by this denominator. So if we would have a different problem, and you do not have to write this, but if we had m divided by 12 equals 7, in order to get this by itself, to get the variable by itself, you would still take the denominator and multiply both sides times +12. Your 12's would cancel out, and you would get m equals 84. As we go to the next slide, we will see a couple more examples, but these are going to focus on using division. So examples, just solving equations with one step, we're going to use division because this problem is a multiplication problem. 7 times x equals 56. Mental math, a lot of you already know the answer. 7 times what value gets us equal to 56? And a lot of you know the answer already. I'm going to show that I know 7 times x can be taken apart or broken down to just x by dividing by 7. If I divide this side by 7, I need to go to the other side and divide by 7 there. 7x divided by 7. 7 divided by 7 is just 1. So we have x. We have 1x, or x by itself. 56 divided by 7 is 8. So that's my answer. And a lot of you got that mentally. Again, you could check it. You could say, does 7 times 8 equal 56? And we understand that 7 times 8 does equal 56. And the next example, this one says 15 times g equals 75. 15 times what value does g have to be to make it equal 75? We can take this side and divide by the coefficient of 15 and do the other side divided by 15. 15g divided by 15 is just 1g. 75 divided by 15 is 5. So our answer, g equals 5. You could double check that and just type into a calculator, does 15 times 5 equal 75? And it does, so you know you got that correct to move on. So any value that you have as a coefficient, if we had 3n equals, let's do 27. Again, mentally, you're looking at it saying 3 times what number equals 27, and a lot of you know that. To show the steps with algebra, we can divide both sides by 3, because 3 times n divided by 3 is just 1n. 27 divided by 3 is 9. We do have to be a little bit careful of some of the rules of dividing by positives and negatives. Okay, if I took a similar problem, and let's say I take, just to be pretty quick here, we'll go 5x equals negative 30. 5 times what number equals negative 30? Well, we know a positive times a negative equals a negative number, so our answer here has to be negative. I'll divide both sides by 5. Negative 30 divided by positive 5 is negative 6. So there will be some problems today where you just need to be a little bit careful of your positive and negative values, your negative signs when you multiply and divide. Okay, now we'll go on to the next and last page of the notes today. So this last page of notes, very similar, but a little bit scary for some of us because this one is solving equations containing fractions. And I do not want to change fractions to decimals. I want to keep them as fractions and just work through them, because when we go to decimals, our calculator will have to round them off. This first problem says 5/9 times v equals 35. So 5/9 times v. I want to undo 5/9 times v to get v by itself. So what we're really doing, and you do not have to write this down, but we're taking 5/9 and we want to divide by 5/9 to get v by itself. Well, when you were in 6th grade and you had a fraction divided by a fraction, Mrs. Wetzel told you to copy the first one, change your division sign to a multiplication dot, so there's copy dot, and she said flip-flop the second fraction, which means take its reciprocal. So when we divide fractions, we can use copy dot flip-flop from 6th grade, and then you can multiply and get 45 over 45, which equals 1. Okay. Or some of you, when you look at 5/9 times 9/5, some of you see that and say, well, I can look at these cross values, and 5 goes into 5 once, 5 goes into 5 once. 9 goes into 9 one time, 9 goes into 9 one time, and you get 1 and simplify it that way. To me, it does not matter if you multiply first and then simplify like we did in green, or if you simplify first like we did down here in red. So the theory that you're using is that copy dot flip-flop. The other theory that you're using that you maybe don't realize is one of the properties we talked about in Chapter 1 called the multiplicative inverse. The multiplicative inverse told us that any fraction, like 5/9, times its reciprocal, 9/5, equals 1. And that's what we want to do. We want to get 1 or just v by itself. We don't want a fraction times v. So when I see this fraction, this 5/9 in front of my v, I multiply both sides times its reciprocal, 9/5. So we just kind of showed you the work that goes behind it, but what you really need to know is any fraction, 9/5, times its reciprocal, 5/9, equals 1. So now you have just 1v. You've essentially canceled out the fractions. Because it's an equation, we do need to multiply this 35 times 9/5. And that can look confusing. So what I like to do is take my 35 and think of it as 35 over 1. And now you've got a couple options. You could do 35 times 9 and then divide by 5. Or you could take that canceling shortcut and say, I know that 5 goes into 5 one time, 5 goes into 35 7 times. And then you get 7 times 9 is 63. 1 times 1 is 1. Well, 63 over 1 can just be written as the whole number, 63. So I get v is equal to 63. This next problem looks a little more confusing. It says 5/2 equals 4y over 3, or 4y divided by 3. This looks like it has two operations. It looks like 4 times y divided by 3. But we can rewrite that. We can think of this problem in the same manner as the previous one. 5/2, or 5 over 2, equals 4/3 times y. 4 times y divided by 3 is the same as 4/3 times y. And now, just like the previous problem, I've got 4/3 times y. And I want to get 1y by itself. So to undo 4/3 times y, you multiply both sides times the reciprocal of 4/3, which is 3/4. And then you have to show me that on this side you would multiply by 3/4. So what's really happening on this right side looks like this. You've got 4/3, and I'm going to use the commutative property, and I'm going to switch these times 3/4 times y. And you know that 4/3 times 3/4, that's reciprocals. That would give you 1y. So that is how we isolate the variable or get y by itself. Now on this side, you've got nothing that cancels out, because 2 doesn't go into both 2 and 3. 4 does not go into both 4 and 5. But you can do 3 times 5, that's 15. 4 times 2 is 8. And you get an answer. Your answer is a fraction, 15/8, and that cannot be reduced, so that's the value. Y is equal to 15/8. So you'll see some of that on your assignment.